Hello and welcome to Sudoku. This is a puzzle that I created for this round of the Sudoku Grand Prix. It was organized by both France and Hungary, and this is one of my puzzles. And this one is called Symmetric Unequal Sudoku. I did not invent the variant, it happened a long time ago in Sudoku Grand Prix, and I just took the inspiration. So apart from the classic Sudoku rules, the constraint is that every time you take two cells that are symmetric from each other with respect to the center of the grid, they must contain different digits. So this digit and this digit must be different. And I set this puzzle a few months ago. I didn't solve it in the meantime, so I forgot almost everything about it. So I'm doing almost a live solve. So let's begin with just plain classic Sudoku stuff. Those twos, put a 2 in this cell. And is there anything else about twos? There must be one in one of those cells by Sudoku, but then by the symmetry rules, this 2 forbids this cell from being a 2. So we get a second 2 here, and there must be one in one of those cells. Next, what's next? Here, 1, 2, and 6 are not in those cells, but they must be here. So we get 1 or 2 here, 1 or 6, 1, 2 or 6. And conversely, 7, 8, 9 are not here, but they must be somewhere on this row, so they must be in these cells. And the remaining cells now must be 3, 4, and 5. So we get 3, 4, and 5 directly. 3 and 3, that's a 3. Always difficult to pronounce for a French person. Next, what do we get? In this box, 1 can't be here, so 1 has to be in one of those cells. And this is not a 1, it's not an 8, it has to be 7 or 9. And this is not 7 or 9, it must be 1 or 8. So you see that we get some restrictions. This one is not an 8, it must be 1, 7 or 9. And something interesting is that this cell must be obviously different from this one, and this digit must also be different from this one. So, well, that's not very interesting in this case, but it would tell us that whenever, let's imagine we put an 8 here, then this is 7 or 9, this is 7 or 9 as well, so this one would have to be a 1. And fun fact, actually this wouldn't work, because then oh, yes, it would work. This would be an 8. Okay, so that's it for this. We need a 4 on this row. It would go here or there. 6 and 6. We get a 6 in one of those cells. And with this, we get a 6 here, which pushes 4 into the other cell. And now 8 can only go here in this box. And now the logic I was referring to applies. Well, actually, you can find it more simply. This 6 makes this a 1, this a 2, this a 6, this an 8. And this 7-9 pair makes this a 1. So this logic was not useful. This is 5 or 9, this is 5, 7 or 9. But now the logic becomes useful. Both cells here see this cell, so this can't be either this digit or this one, so it has to be a 5. Making this a 9, this a 7, this a 7, this a 9. Well, of course there are other ways to resolve this part of the grid, but I like this way of doing things. Now, the center has been completed. Let's have a look at the rest of the grid. This 2 makes this a 2. And this column now needs 1, 8, and 9, and there's really not much to do with that. This column needs a 1, it's not here, it's there. It also needs a 4, a 9, and 5. Oh, so this is a naked single, that's a 4. And this is 5 or 9, this is 1 or 9, 1, 5 or 9. This can only be 5, 7 or 9, that's not very interesting. This is not 7, 8, so 7 and 8 need to be in those cells. Then that's a 6, that's a 3, using this 6. Four goes here, that's a 1, that's a 5, making this a 9. And we get a 1 and a 5. Those must now be 2 and 8. And for the time being, we don't really need the symmetric constraint. We need a 3. It's here. That's a 7, making this an 8, this a 7. And those must be 5 and 6. Oops, 5 and 6 this way. We need 1, 8, and 9, and with this, we know that this is a 9, this is 1 or 8. And now, the logic I was referring to earlier works again. This cell is different from this one and this one, so it must be a 9. Those cells now must have 2, 6, and 7, so this one is a 7, and we get a 2, 6 pair. We still need 1, 8, 3, and 4 somewhere. Too early to pencil mark, I guess. Here we need 1, 3, and 9. So this is 3 or 9, this is 1 or 3. And we can check that there's nothing to gain from this. Here we need 4, 3, and 7. This 4 says that this is 3 or 7, 3 or 4 here, using this 7. This must be 6, 8, and 9. This one is not a 6, it's not a 9, so it's an 8. And that's a 6, that's a 9, making this a 2, this a 6, this an 8, this a 2, and that's a 3, that's a 1, that's a 9, this is a 1, this is not a 3, and this one makes this an 8, and this a 1. Here we need 3, 4, and 8. So this is 3 or 4, and it gives us a 5 at the end of the row. And we need here 4 or 7, making this an 8. This is 3 or 4, and this is 4 or 7. And how do we resolve that? Oh, this 7 makes this a 4, that's a 7, that's a 3. And we get the remaining digits, which wraps up the solve of this symmetric unequal Sudoku. And I hope you liked this puzzle. I hope you enjoyed this video. Thanks for watching and see you soon on Sudoku.